All right, you guys, I'm going to give you a brief outline on how to run a multiple regression. So here's the data set, child aggression, and relationship between aggression. That's the DV and several predictors. These are all your IVs, right? A predictor is an IV in a multiple regression, and this is the DV. The DV can also be called the output or the criterion. And I'm going to call these predictors because they're trying to predict aggression scores through the parenting style, diet, computer games, television, and sibling aggression. So here we go. You're going to go to, let's put it down where you can see it. Analyze, regression, linear. So the DV is aggression, and all these other guys are independent variables, predictors, if you will. Now we're going to click those, and then we're going to go to statistics. And I just do this by automatic, done it a million times. He doesn't hit you with the assumptions, so neither am I. But I do them automatically. So if you want to learn about these assumptions, go to the Hawk 3. That's okay. And down here on the bottom, it says okay. We're going to click okay. And here is your output. So let me get the important ones for you. Please hold. Question 1A, which variable has the strongest bivariate correlation? So bivariate correlation is a Pearson's correlation, and in the chart it's called the zero order correlation. So that is the correlation between parental style and aggression by itself, and it is the strongest. Number B, which is the weakest? Looks like diet. Let's go back up here. Diet. Where's it? Right there. Bam. That's the weakest. Based on which variable do you expect to be the strongest predictor? No brainer, parenting style. So what I tell by strength is I use the beta weights. The beta weights are the standardized coefficients. All that means is that it takes the unstandardized B coefficient divided by the standard error. So if you divided this 0.033 by 0.046, you should get that. I don't know if that's right or not. So never mind, just keep going. As a set, how much variance does this predictor explain in the aggression? That is going to be, whenever you hear variance explained, that is your effect size, also called coefficient of determination. It is also called your R squared. So you can explain about 8.3% of the variance in the DV. Let me write that down, 0.3% from this model, which is kind of medium. I mean, it's not the greatest in the world, but hey. Beats poke in the eye. And E, is this amount significantly statistical? Is this statistically significant? So that's when you go to your ANOVA table. And yes, your ANOVA is significant. It's less than 0.05. Therefore, this multiple regression is significant at predicting aggression. That doesn't mean that all of these predictors are going to be significant predictors, but it means that at least one is, okay? So I think that's it for number one. Oh, no, wait. Based on the effect size conventions given in the lecture notes, is this a small, medium, or large effect size? So he's got a different, his numbers are a little bit different than mine. So since we use R squared, I'm going to call it, because it was 0.083, I'm going to call it between medium and large effect size. So in other words, it is a believable model. Which individual predictor are statistically significant, and how do you know? So let's look at the ones that are significant. You simply go to the coefficient box. You look at the significance column. Anything less than 0.05 is significant. So computer games is significant in prediction aggression. Sibling aggression is significant at predicting aggression. Diet, even though it's small, is significant at predicting aggression. And parenting style is the king, and that is, the only one that is not is television, but that rots your brain. Provide an interpretation of the value of the regression constants in the problem. The constant of negative 0.005 indicates that before you start this test, then the average aggression should be somewhere around 0.005. Another way to put it is when all the other variables are zero, which means before you start, then the aggression score should be around negative 0.005 for everybody. All right, an interpretation for the value of the unstandardized regression coefficient for parenting style is this, right? So what that literally means is for every single parenting style unit, when it goes up by 1, the aggression score should go up by 0.057. I'll say that again. When the parenting style goes up by 1 score of whatever the units are for parenting style, then the units for aggression goes up by 0.057. Now, I'm big on the prediction equation. So here it is. The predicted aggression score is the constant, it's this, plus or minus all of the significant unstandardized B weights. That's these guys. Only those that are significant. If it's not significant, don't put it in the equation. But here it is right there. Okay. So if you wanted to predict somebody's aggression scores, you would find out what their computer game scores are, their sibling aggression scores, their diet scores, and their parenting style scores, and then multiply them all together, and then add them and subtract them, and this is it. This is your prediction score. All right, J. So the interpretation of the value of the standardized regressions for sibling aggression. So standardized regression for sibling aggression is... So let's look at the standardized columns first. That's these. The beta weights are standardized coefficients. And he wants sibling aggression right there. Now these units are standard deviations. So what this means is when a sibling aggression score goes up by 1 standard deviation, then the aggression score should go up by 0.084 standard deviations. So the standard deviations change in value, but the units are still standard deviations. So it's clever. And then based on the semi-partial correlations, which SPSS calls parts, don't ask me why, which predictor seems to be the most important in explaining child aggression? Interpret the strongest squared semi-partial correlation in terms of that. So that is right there, still parenting style. But it's still, if you'll notice, you got a real close behind with computer games. But parenting style has the largest semi-partial, and when you square it, you get 0.021. So what this means is that parenting style can explain about 2.1% of the aggression by itself, without any overlap from the other predictors. Okay, so that's what that means. All right, let me get down here to number 2. Question number 2, same as number 1 with one big change here. You're going to enter computer games by itself in step 2. This is what we call a hierarchical regression. That means you pick the order in which to put your predictor variables in there. So let's give it a go. Where's my data? There's my data. Get in there. There you go. So we're going to go to Analyze, General Regression, Regression, Linear, and so let's see, what was it, Computer Games? Okay, everything else should be the same. I'm going to hit Enter. No, I'm going to hit Next. Hit Next. Okay, so that cleans it out. So it's going to make a separate model with computer games added to the rest of the predictors that we put in. So the first model is going to have these 4 predictors, and the second model is going to have those 4 plus this one. And it's going to show you if this one by itself had a significant predicting power. I always thought that was kind of cool. Everything else should be the same. I'm going to go down here and hit okie dokie. So let's take a look. There it is. Hold on. In the blink of an eye. Question 1, what hypothesis does this analysis seem to test? I would think that it would be this. That aggression scores can be significantly predicted by one or more of the following predictors. And that's all of them: parenting style, diet, sibling aggression, television, and computer games. Or he might think about it like this. Because it's a hierarchical, then he might want you to answer the question about computer games, like will adding computer games to the predictive model make a predictive model or not make it a stronger predictive model? So we might be asking for a hypothesis that when adding computer game to the other 4, it makes it more significant predictor. But I'm not 100% sure what he's looking for there. So, man, thank God for spell check. Okay, now B. Is there a statistically significant difference between Model 1 and Model 2 in terms of variance explained? So that's when you're going to go to your R-squareds. So there's the first model, right, without computer games, and it is a significant predicting model. Once we throw in the computer games, right, so A is Model 1, B is Model 2. You'll notice that the last predictor added is computer games. That's what hierarchical does for you. And it changed the R-squared from 0.062 to 0.083, and it's got the R-squared change here. And then you go down here to see if that change was significant, and it was, right? So adding the computer games did significantly change the effect size. So congratulations. And that's what this means up here, right? You look at significant F change. So let's say we put them in one at a time. You know, you have 5 predictors and we put in 1 next, 2 next, 3 next, etc. You would have 5 different models, right? And anything that was a significant predictor would have a significant F change. If not, this value would be greater than 0.05. So moving on. What does the change in R-square mean in values? It means that you can predict more. Your model is stronger. You can explain more of the variance in the DV. That's what it means. So the bigger the R-squared, the better. So in other words, when they added this computer games, it strengthened this prediction model. Notice any similarities from Part K above? And the results of the analysts. What was it? And Part K's were what was Part K? Semi-partials. Boom. Explaining variance. Okay. So I'm not sure what he's asking about this question. Okay, so, but what I'm sure it has to do with, you know, the amount of variance that you can explain. So what it is that your first model is better at it explains more of the variance in a DV than the second model. Maybe that's what he's saying. But then, you know, I pulled up the partials and core semi-partials. So there's the first model right here. This is without computer games. And then here's the one with computer games. So you'll notice that things changed a little bit, right? Parenting style went down a little bit. Diet went down a little bit. Sibling aggression went down a little bit. Everything went down a little bit. So in other words, that computer game thing seems to be overlapping with the rest of these variables. So that's it in a nutshell. I strongly suggest that you guys go to the Hawk 3 and read all the little stuff, watch all the little videos, and, you know, get good at multiple regression. Multiple regression is very, very important in statistics. It gets used a lot, so get good at it. That's it. MGZ out.